So, section 10.4, basically we're solving trig equations, and you've done this before back in chapter 8. The only difference now is that you've got your additional half angle and double angle and addition and subtraction angle formulas that you're going to be able to work with when solving the equations. For example, looking at this first one, we see cosine 2x. We know we've got three formulas for cosine 2x. And we also note that we've got a 2x, cosine 2x, and sine x. Generally, solving these trig equations, we want everything in terms of, say, 2x or 4x or something, or we want everything in terms of just x. So, to jump in on this first one, I look and note that I've got three possible formulas here, choices for cosine of 2x, and I've got a sine x here. So I'm actually going to pick the one with just sines and hope that something's going to happen with factoring. So we know for cosine 2x, it's going to be 1 minus 2 sine squared of x minus sine x equals 0. And note, I'm asked to solve this from 0 inclusive to 2 pi exclusive. So now I'm down to here. I see I've got a quadratic expression. I'm going to multiply everything by -1. Rearrange 2 sine squared x plus sine x minus 1 equals 0. I'm going to factor for a 2 sine x and a sine x. My only factors of 1 are 1 and 1. I need to get a plus 1, and I need to get a plus sine x rather. And so a negative sine x and a plus 2 sine x will give me a plus sine x. Negative 1 times 1 gives me a negative 1. 2 sine x times sine x gives me, indeed, 2 sine squared x. So then I set each factor equal to 0. 2 sine x minus 1 equals 0. Or sine x plus 1 equals 0. And this gives me sine x equals 1/2. Or sine x equals -1. And therefore, sine x equals 1/2, we know that's going to be true at pi over 6 or 5 pi over 6. And sine x equals -1 at 3 pi over 2. So I've got three solutions here for this one. And again, similar problem, but again, just to show you, again, your choice for the cosine 2 theta is going to come into play. You get the three choices: cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. With a cosine here, I'm going to pick the 2 cosine squared theta minus 1 minus cosine theta equals 0. Rearrange 2 cosine squared theta minus cosine theta minus 1 equals 0. Factor 2 cosine theta, cosine theta. I know I've only got a 1 and a 1. I want a negative, so I'm going to go a negative here, a positive here. So cosine theta equals -1/2, or cosine theta equals 1. And again, note that up here in my solution set, 0 is not permissible, so cosine theta equals 1 at 0 or at 360, so I'm not going to get anything there. Cosine theta equals -1/2 at, let's see, spinning around, cosine theta is negative over here. For it to be 1/2, that's going to be a 2 pi over 3. And if I keep spinning around a little further down to here, that's going to be a 4 pi over 3. So two solutions here. So seemingly a pretty simple one here in terms of looking at the equation you got to solve. 2 sine x minus 1 equals 0. But you're asked to solve for all real numbers. And this little symbol here, which I can draw a little more accurately, that little symbol means is an element of, and we remember that our notation for all real numbers is a vertical bar and then an R next to it. So we're looking for all real solutions, not just between 0 and 2 pi or between 90 and 180. We're looking for all solutions. And so we solve, and let's get some specific solutions first. So we get sine x equals 1/2. And if I think about between 0 and 2 pi, where sine x equals 1/2, that's pretty easy. That's going to be at pi over 6, or it's going to be at 5 pi over 6. Well, let's think about it. When's the next solution? If I'm looking at where the sine graph equals 1/2, here's my sine graph. And I've just found two solutions. I found the one here at pi over 6, and I found the other one here at, right here at 5 pi over 6. Where's the next one? Where are the next solutions going to be? Come across here at 1/2. Right over here and right over here. Well, how many radians do I have to go to get from here to here to here? That would be 1 period. How many from here to here? That would be 1 period. So I know that the next solution, for example, for the pi over 6, would be pi over 6 plus 2 pi. What would be the next solution be after that for here? That plus another 2 pi. What would be the next solution? Plus another 2 pi. So we've talked about this a little before. We could just say plus 2 pi n, where n's an integer, or ditto for the 5 pi over 6. I have a solution here. I go a full period. I get the next one. So 5 pi over 6 plus 2 pi n, and n is an integer. Now what about working backwards? Well, if I work backwards with a sine graph on the other side over here, right, to get from here back to that solution before, what would I do? I'd subtract 2 pi. Well, subtracting 2 pi, what happens if I let n be -1? Well, that's going to subtract the 2 pi and take me back to here. How about for this one here? Subtract 2 pi is going to take me back to here. So with n being any integer, indeed, my solutions are pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n, where n is an integer. Now, for this one, we're solving between 0 and 2 pi. Note interval notation. Include 0, exclude 2 pi. Our bracket includes the endpoint. Our parenthesis does not. So I look at this one, it looks very complicated. I've got sine 2x's, I've got cosine 2x's. Wow, do I want to expand this and get everything in terms of x? And wow, it's looking very long and complicated. However, what do you recognize here? That's a formula. That's one of our expansion formulas for sine. So I want to rewrite this immediately as what? Sine of 2x plus x equals 1. And that means that I'm looking at sine of 3x equals 1. And I look at that for a minute and go, okay, well, the sine of some angle has to equal 1, and that we know is going to be at pi over 2. So that 3x there has got to equal pi over 2 plus 2 pi n, where n is an integer. Now I want to solve for x, so if I divide each side by 3, I get x equals pi over 6 plus 2/3 pi n, where n is an integer. And now I ask, okay, I want to solve and get all solutions here between 0 and 2 pi. Let's see what values, if I start plugging in values of n, what's going to give me solutions between 0 and 2 pi. If I plug in 0 for n, pi over 6 plus 2/3 of 0 is pi over 6. So pi over 6 definitely is a solution. I'm going to write that right there. What happens if I let n be 1? If I let n be 1, then I'm going to get pi over 6 plus, let's see, 2/3 of 1 would be 4 pi over 6. So that's 5 pi over 6. Is 5 pi over 6 still between 0 and 2 pi? Indeed it is. So 5 pi over 6 is going to be a solution. How about if n equals 2? Well, if n equals 2, then I'm going to get pi over 6 plus let's see, 4 pi over 3, change that to sixths, that would be 8 pi over 6. So that would be 9 pi over 6, or 3 pi over 2. Yep, that's still between 0 and 2 pi. And finally, what happens for n equals 3? For n equals 3, I get pi over 6 plus, let's see, that would be, for n equals 3, that would be plus 2 pi. And note that 2 pi plus pi over 6 is going to be bigger than 2 pi. So my three solutions then are right here. And if I want to simplify those a little, I get pi over 6. I get 8 pi over 6 is 4 pi over 3, dividing everything by 2. And 9 pi over 3, divide everything by 3, I get 3 pi. Whoops, that was supposed to be a 9 pi over, sorry about that, that's a 9 pi over 6. Dividing everything by 3, it's going to be a 3 pi over 2. So there are my three solutions between 0 and 2 pi. So, looking at this one here, I see a cosine of alpha minus beta, and I might think, oh, I want to expand this real quickly. Cosine of 57, sine of 57 is not looking very friendly, though. Furthermore, I'm asked to solve this a little different. I'm asking you to find solutions for x between negative 180 and positive 180. So we look at this one and go, with this being negative 1 here, I can look at this as looking at a cosine of u equals negative 1, and I then know that u, pretty quickly working in degrees, could be 180, u could be negative 180. If I were to add 360 to each of those, I could get a 540. I could get a 540. And if I add 360, negative 540, etc., etc. So I look at those for a minute and say, okay, if I set those u values equal to x minus 57, am I going to get any x solutions in between negative 180 and positive 180? Well, let's find out. Let's see. X minus 57 equals 180. 57 comes over to the other side. I get x equals 237. That's not between negative 180 and positive 180. So 180 is out. How about negative 180? Let's see. X minus 57 degrees equals negative 180. And move the 57 over. X equals negative 180 plus 57. And indeed, that's going to give me an answer in between negative 180 and positive 180. That turns out to be, if I do my arithmetic correctly here, I believe negative 123. Negative 123 is between negative 180 and positive 180. If I were to look at these other numbers, I can see pretty quickly that they're not going to give me solutions for x just visually in between negative 180 and positive 180. So I get one solution here, x is negative 123 degrees. So let's consider a problem here. We've got sine of x over 1 plus cosine x equals 1. We'll look at two ways to solve it. If I can recognize that's a half angle formula from tangent, I then know that I'm looking at tangent of x over 2 equals 1. I was asked to solve for x between 0 and 2 pi, so then x over 2 will be between 0 and pi. So what angle has a tangent? What angle has a tangent between 0 and pi equal to 1? And the only angle is pi over 4, because at 3 pi over 4 the tangent would be negative 1. So therefore, my x over 2 has to equal that angle. X over 2 has to equal pi over 4, or x equals pi over 2. Okay, so another way to look at this, if we didn't recognize our tangent formula here, just say, if 1 plus cosine x can't equal 0 because it's in the denominator. So if we multiply both sides by 1 plus cosine x, maybe that'll help us. And we get sine x equals 1 plus cosine x, noting that 1 plus cosine x can equal 0. We look at that, and we still have no clue. That's not really helpful. Well, one thing that we did in the past at times, particularly if we had a square root on one side of an equation, we wanted to solve it, is we squared both sides. And then we checked for extraneous solutions at the end. So if two numbers are equal, then their squares will be equal, provided they're both equal. Now, sine x would have to be a positive number, 1 plus cosine x a positive number. If those positive numbers are equal, then their squares will be equal. If this is a negative number, and 1 plus cosine x is a negative number, well then square the two negative numbers that are equal, they'll be equal. So we got to check for extraneous solutions if we square both sides of the equation. So I'm going to go ahead and get sine squared x equals 1 plus 2 cosine x plus cosine squared x. Remembering all along from now on that 1 plus cosine x can't equal 0. And at this point, I see I've got a sine squared, and everything else is in terms of cosine squared. So I can take care of, with the Pythagorean identity, 1 minus cosine squared x equals 1 plus 2 cosine x plus cosine squared x. Ones will cancel. Let's move the cosine squared over to the other side. I get 0 equals 2 cosine x plus 2 cosine squared x. Factor out of 2, 0 equals cosine x plus cosine squared x. Factor out of cosine x, 0 equals cosine x times 1 plus cosine x. And at this point, we then know that cosine x equals 0, or 1 plus cosine x equals 0. Now note, up above we said 1 plus cosine of x cannot equal to 0, so we can't include looking at this to get solutions. So the question is then, where does cosine x equal 0? Cosine x in the interval of 0 to 2 pi, cosine x equals 0 at 90 degrees. Whoops. At 90 degrees, or at 270 degrees. And again, at this point, we want to check whether both of those solutions are good, because we squared both sides. We want to actually go back up to our original equation here and see if both of these solutions work. Putting a 90 in, sine of 90 is 1, cosine of 90 is 0, 1 over 1 equals 1, 90 works, it's a solution. Putting in 270, let's see, the sine of 270 is negative 1, the cosine of 270 is 0, negative 1 over 1 is negative 1, does negative 1 equal positive 1? And the answer is no. So 270 is an extraneous solution. So my only solution here is 90 degrees, or, since we were working in radians up here, is pi over 2. That's my only solution.